And joining us now is Benjamin T. He's from the National University of Singapore. Good to see you. And your virtual Symposium X talk is actually titled AI Skins for Good. Give us a preview.
Sure. So what I'll talk about is how we can combine material science and engineering to develop devices that AI algorithms can take advantage of for wearable health applications as well as for prosthetics or neural applications.
And researchers have been working on stretchable electronics for some time. Your work expands on that to include reading and interpreting what could be massive amounts of data from wearable sensors. How do we process all that data, and what can be some of the benefits of doing so?
Yeah, I think that's a great question. I think that processing very large amounts of data is becoming very important as we're making these devices a lot more sophisticated. They can collect a lot more signals in a multiplexed manner. And we will have to work with neural algorithms that can filter and process this data very quickly and importantly power efficiently, because otherwise you will end up having to wear a very big battery, which obviously becomes makes it unwearable. So that's also really where I think working with neural machine learning algorithms and even newer ideas around how we can collect this data and then sort of feed that back into device design and materials engineering. That is very important.
What led you to studying this area of materials science?
So I got fascinated by the idea that a computer can be flexible, stretchable, or even soft like skin. During my undergrad research program when I was studying in University of Michigan, where I was developing an inkjet printable semiconducting inks that can be put onto plastic substrates, and that kind of got me started thinking about, wow, I can actually, through material science, using neural materials, make them compute, right? And my background is in electrical engineering, which can be quite dry and boring, but the material science aspect of that really fascinated me and drew me into that, and that's how I got started looking at flexible electronics and flexible devices.
And what are the next steps or the next discoveries still out there that you'll be working on?
Yeah, I think that I'm increasingly very interested in the field of medicine, right? And I'm also starting to look at, actually we are already collaborating significantly with clinicians interested to make use of some of our materials, new kind of materials, new kind of devices, right, that can help them improve their clinical practice and collect the kind of relevant data that can improve their patient outcomes. Right? And so that's kind of where I'm very interested in working very closely with clinicians. But creating any new medical technology requires a longer lead time because of regulations. But it's a good start when you start talking to doctors and uncover problems that they face.